ladies and gentlemen, so today we're going to look at how we can use those properties and help us to be able to explain why we do what we do when we are simplifying, using PEMDAS to simplify an expression. And then we'll also end up applying it to our equation solving. So this is really to try to get you to think about what you're doing and why you can absolutely do that. So we have our first few examples we have some problems that are worked out, right? They basically went through and they did PEMDAS on this to figure out that this whole thing up here actually is equal to 7. And what we're going to do is we're going to try to figure out, well, number one, what did they do to get from one step to the next? And what property lets us actually be able to do that? So when I look at this first example, I know they started with parentheses, right? And so they basically took this 4 minus 3 and they put the 1 in. Well, when you take out one quantity and you put another, if you remember from over here, that is our substitution property. So we're going to write down the reason we were able to do this is because of the substitution property. And I'm going to abbreviate. Now, to go from this line to this line, the next thing they did was they did their multiplication. So they multiplied here. Now, substitution technically would work, because you could really just fill in substitution all the way down. But substitution is kind of the last resort one. If any of these other ones work, things like additive identity, additive inverse, multiplicative identity, multiplicative inverse, commutative, associative, you want to look for those first, okay? So because I was multiplying by 1, right, because that's what I did. I multiplied by 1 and I got 7. Well, when you multiply by 1, that is your multiplicative identity. Or you could say identity of multiplication. I don't care which way you write it. Then we went through and we did this problem and we did 5 times 1/5 and we got an answer of 1. Well, 5 and 1/5 are reciprocals or inverses of each other, which means this was multiplication. I'm going to rewrite it. I don't want to do it that way. Sorry. Is the inverse property for multiplication. I'm going to use an X for multiplication. So to get from this step down to this step, they did 7 minus 1 and they got 6. That was substitution. There isn't anything else special about that. And then to get from 6 plus 1 down to 7, another substitution. So you should not ever have, I shouldn't say that, most times you should not have substitution all the way down. Right? It shouldn't work that way. All right, so let's try number 2. So this is new, this is different, this is going to take some practice, and that's okay. So here we have, going down here, we have 4 times 2, right inside my parentheses, I did the 4 times 2 first to get the 8. That was just a substitution. Now we finished off our parentheses, but we have 8 minus 8. Well, 8 minus 8 to get 0 is really inverses. So this is the inverse property, but for addition. Right? Because 8 and negative 8, because we're going to look at the sign of what's in front, 8 and negative 8 are inverses of each other. All right, to get from this step down to this step, so we did 2 times 3, we got 6. That's your substitution. Now we did 6 plus 0. Well, 0 is your identity for addition. So this is identity for addition. So it's, again, putting a bunch of different things together. Yes, it's different. I know you guys can handle this. All right, let's try this next one. So here we went from 5 times 7 times 4 times 2, and it looks like all I did is I grouped them together. I put the 2 with the 5 and I kept the 7 and 4. Well, that means, right, we went from this one over here, now they're together. Well, the property that says that I can change the order is the commutative property. This one happens to be commutative for multiplication because they're being multiplied. Then, to get from this step down to this step, I put in some parentheses, some grouping symbols. So when you put in those grouping symbols, it's the associative. And make sure if you're aiding associative, you include the OC. Then we did 5 times 2 to get 10, 7 times 4 to get 28. That was just substitution. There's nothing else special about those. And then 10 times 28 is 280, also substitution. All right, number 4. So this time we went through and we got rid of our parentheses, right? We used, if you look at that, that's the distributive property. Right? You can distribute those. Now when I look to see, okay, well, what are they doing to get from this line down to this line? They've moved the 2x over next to the 3x, and they put the 6 with the minus 2. So when you change the order, it's the commutative property. This one is for addition because it's an adding and multiplying. Then they did the actual problem. 3x minus 2x was x, 6 minus 2 was 4, so that's your substitution. All right, now let's go through and actually try one where we have to do it ourselves. But I'm going to rewrite this because this isn't supposed to say 1 divided by 5. It's supposed to say 1/5 times 5 times 14. So if you could make that change for me. So if I were to go through and do this, I have to do parentheses first, or multiplication first, from left to right. So I have to do 1/5 times 5. Well, 1/5 times 5 is 1. But 1/5 and 5 are inverses of each other. So the reason this gave me an answer of 1 is because it's the inverse for multiplication. Now I'm going to do 1 times 14. Well, I know my answer is 14. Okay. Well, this is the identity. Whenever I multiply anything by 1, it's the identity for multiplication. All right, we're going to do 7 and 8 together in class. I want you to try number 6 on your own. And we'll give the answer. But we'll do 7 and 8 together in class. I want you to try number 6 on your own and bring it to class with you, and we'll see how you did. Any questions? As always, bring them to class. Have a good night.